Hi, everyone. This is Peipei Zhou. I'm glad to present our work, MOCHA. MOCHA stands for Multinode Cost Optimization in Heterogeneous Cloud with Accelerators. This is work that I had been working on when I was a PhD student at UCLA. Currently, I'm serving as a tenure-track assistant professor at University of Pittsburgh, Electrical and Computer Engineering Department. In this work, we use Genome Analysis Toolkit, GATK, as application driver, while the FPGA accelerator achieved huge kernel speedup due to the massive parallelism and huge computation intensity. When we deploy the accelerator in public cloud, one of the key questions arises that how does using FPGA accelerators impact an application out-of-pocket cost in public cloud services, such as Amazon Web Service, Google Cloud, or Huawei Cloud? It turns out that using FPGA usually brings in benefit in getting a smaller runtime. However, it does not guarantee cost savings. For example, when we deployed HTC, one key application in GTK in AWS cloud by using FPGA accelerator, the latency improves by 1.6x. However, as shown in the right chart, the cost improves by 2.6x. Similarly, when we deploy Mutex2, another key application in JDK in Huawei, with FPGA accelerator, the latency improves by 1.5x. However, the cost increased by 1.16x. Why is that? Firstly, FPGA is not cheap in public cloud. In AWS, one FPGA is priced at around 25 CPU cores. In Huawei Cloud, one FPGA is priced at 23 CPU. However, due to Amdahl's law, the theoretical speedup is always limited by the non-accelerated part. For example, in HTC, PowerHM kernel that can be accelerated takes only 39% of the whole application. The application speedup is thus bounded by 1.6x. In this case, the CPU FPGA instance is priced at 4x more than pure CPU instances, and what users pay for FPGA does not bring throughput improvements in return. And this applies to different applications where the accelerated portion ratios are different and the accelerator speed up are different. In order to model and optimize the cost when deploying FPGA accelerators, we summarize 3 cases in CPU FPGA platform. The first one is well-matched FPGA and CPU, where the throughput of CPU cores and the FPGA accelerators match each other. The second case is fast FPGA, where the FPGA resource is not fully utilized and wait for CPU to either produce the data or consume the data. The third case is slow FPGA, where the CPU resource is not fully utilized and wait for FPGA resource to either produce the data or consume the data. For the third and the second cases, either FPGA or CPU is not fully utilized and the allocated resource is waited. To optimize the second case, we propose to launch more CPU nodes to fully utilize the FPGA nodes to match the throughput of CPUs and accelerators. To optimize the third case, we propose to offload accelerated kernels back to CPUs to keep CPU resource fully utilized instead of waiting for the offloaded task to be finished on FPGA. We integrate these optimization techniques and the proposed MOCHA as shown here. MOCHA first uses application profiling and application accelerator speedup to calculate the optimal CPU FPGA resource allocation schemes, then set up the cluster and request the resource on public cloud. MOCHA runtime launches Node Accelerator Manager to communicate with CPU clients and FPGA accelerators to fully balance the workloads. By using MOCHA, we bring down the cost by deploying FPGA in AWS by 2.7x with less than 5% performance degradation for HTC applications. And by using MOCHA in Huawei Cloud, we bring down the cost by 1.5x with 1.5x speed up as well in the application runtime. In conclusion, MOCHA provides an optimal CPU FPGA resource allocation in terms of cost in public cloud. If you are interested in knowing more about MOCHA, please don't hesitate to email me, and I'm more than happy to answer. Thank you for your time.